When installing a standby generator with an automatic transfer switch, or ATS, to an existing 200 amp 3-phase service, the question of whether an additional service disconnect is needed between the meter and the ATS often arises. According to the National Electrical Code, on NEC, if the generator set is equipped with an integral main breaker, then no, an additional service disconnect is not required between the meter and the ATS. In this scenario, where the main panel is located directly on the other side of the wall from the meter, the ATS can nipple through the wall to refeed the main panel directly. The integral main breaker on the generator set acts as the main service disconnect for the system when the generator is in operation. Several sections of the NEC are relevant to this installation. Firstly, NEC 700.12 states that enclosures for service equipment shall not be used as enclosures for other equipment or apparatus. This means that the ATS and the generator's integral main breaker must be housed in a separate enclosure and not combined with the service equipment enclosure. Secondly, NEC 700.23 requires the service equipment be readily accessible. The ATS and integral main breaker must be located in a place that allows for easy access for inspection, maintenance, and operation. The location next to the meter base typically satisfies this requirement. It is crucial to ensure that all wiring and connections adhere to the NEC and local electrical codes. The size of the conductors, the grounding system, and the overcurrent protection devices must be appropriately sized for the load and the available fault current. Conductors must be sized appropriately based on the ampacity and any applicable dirting factors. For example, Table 310.15b16 in the NEC provides ampacity ratings for insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air and various raceways. The grounding system must be installed according to NEC Article 250, which outlines the requirements for grounding and bonding. Proper grounding ensures that fault currents can safely return to the source, minimizing the risk of electrical shock and equipment damage. Overcurrent protection devices, such as circuit breakers and fuses, must be selected based on the ampacity of the conductors and the rating of the equipment they protect. NEC Article 240 provides the requirements for overcurrent protection. It is also important to consider the generator's starting characteristics and ensure that the overcurrent protection devices can handle the inrush current during generator startup. The ATS must be listed and labeled for its intended use and be suitable for the environmental conditions at the installation location. The ATS should be installed according to the manufacturer's instructions and all applicable codes and standards. Proper coordination between the generator, the ATS, and the main panel is essential for a safe and reliable standby power system. A licensed electrician should perform the installation to ensure that all work is done in accordance with the NEC and local electrical codes. Furthermore, the installation should be inspected by a qualified electrical inspector to verify compliance with all applicable requirements. When dealing with electrical installations, safety is paramount. Always to energize circuits before working on them and use appropriate personal protective equipment, such as gloves and safety glasses. Work should only be done when the absence of voltage has been verified with a calibrated meter. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. They have the knowledge, skills, and experience to do the job safely and correctly. In summary, when adding a 30 kilowatt standby generator and ATS to an existing 200 amp 3-phase service, an additional service disconnect between the meter and the ATS is not needed if the generator set has an integral main breaker. The ATS can refeed the main panel directly, provided that the installation complies with all applicable requirements of the NEC and local electrical codes. Always prioritize safety and consult with a qualified electrician to ensure a safe and compliant installation. By adhering to these guidelines, you can ensure a safe, reliable, and code-compliant standby power system. The integral main breaker within the generator serves as the essential disconnect during generator operation, satisfying NEC requirements without necessitating an additional disconnect. The ATS must be appropriately sized to manage the full load transfer between utility power and generator power, and the selection must align with the power requirements of the connected loads. Additionally, all grounding and bonding connections must be meticulously installed to comply with NEC Article 250, ensuring a secure and effective path for fault currents. Consideration should be given to the specific voltage and phase configurations to ensure that the ATS is compatible with both the utility supply and the generator output, and any discrepancies could cause equipment malfunction or damage. Furthermore, the ATS installation should include surge protection to safeguard against voltage spikes and transients which can damage sensitive electronic equipment. Regular maintenance is also crucial for the reliable operation of the standby generator system and should include periodic testing of the generator and ATS to ensure they perform as expected during a power outage. It is also advisable to keep detailed records of all inspections, tests, and maintenance activities, and this documentation can be useful for troubleshooting and demonstrating compliance with regulatory requirements. Local permitting requirements should be checked before starting the installation and often require submitting plans and obtaining inspections, and failing to comply with permitting requirements can result in fines or delays. Moreover, coordination with the local utility company may be necessary to ensure that the generator system is properly integrated with the electrical grid and prevent any potential backfeed issues. In situations involving critical loads, such as hospitals or data centers, additional considerations may be necessary to ensure an uninterrupted power supply, and this may involve implementing redundant systems or uninterruptible power supplies to bridge the gap during generator startup. Furthermore, consider any potential environmental factors such as noise levels or emissions from the generator, and steps should be taken to minimize any negative impacts on the surrounding community. The choice of fuel for the generator also plays a role, with natural gas and propane being common options, with each having its own advantages and disadvantages, and factors such as availability, cost, and environmental impact should be considered when selecting a fuel type. Overall, a comprehensive approach to planning, installing, and maintaining a standby generator system is essential to ensure its safe and reliable operation, and seeking guidance from qualified professionals can help to navigate the complexities of these systems and ensure compliance with all applicable requirements. For instance, the transfer switch chosen should be listed under UL 1008, which is the standard for transfer switch equipment, and this listing ensures that the transfer switch meets specific safety and performance requirements. Also, the generator should comply with EPA emission standards, especially in areas with strict environmental regulations, and selecting a generator that meets these standards helps minimize air pollution. In addition, the generator should have adequate ventilation to prevent overheating and ensure proper combustion, and this is particularly important for generators installed indoors or in enclosed spaces. Moreover, when installing the ATS, ensure that it is properly labeled to indicate its function and operating instructions, and clear labeling helps prevent confusion and ensures that authorized personnel can operate the system safely. Also, the ATS should be equipped with a manual override feature that allows authorized personnel to manually switch between utility and generator power, and this feature can be useful during testing or in the event of an ATS malfunction. In cases where the generator is located a significant distance from the ATS, voltage drop calculation should be performed to ensure that the voltage at the ATS remains within acceptable limits, and voltage drop can affect the performance of equipment connected to the generator. Furthermore, consider the potential for harmonics generated by nonlinear loads, and harmonics can cause overheating of transformers and other electrical equipment, and can be mitigated by using harmonic filters or by selecting equipment that is less susceptible to harmonics. When connecting the generator to the ATS, use flexible conduit to minimize vibration and stress on the connections, and flexible conduit helps prevent damage to the connections caused by generator vibration. Also, when selecting conductors for the generator and ATS connections, ensure that they are rated for the appropriate temperature and environmental conditions, and high-temperature conductors may be necessary in hot environments. The neutral conductor should be sized appropriately to carry any unbalanced load current, and undersized neutral conductors can cause overheating and voltage distortion. In addition, the grounding electrode system for the generator should be bonded to the building's grounding electrode system to provide a common ground reference, and this bonding helps prevent voltage differences between the generator and the building electrical system. Furthermore, surge protection devices should be installed at both the ATS and the main panel to protect against voltage surges from both the utility and the generator, and surge protection devices help prevent damage to sensitive electronic equipment. Also, the generator should be equipped with a low oil shutdown feature that automatically shuts down the generator if the oil level drops too low, and this feature helps prevent engine damage due to lack of lubrication. The generator should also have overspeed protection that shuts down the generator if it exceeds its rated speed, and overspeeding can cause mechanical damage to the generator. The generator's fuel supply should be protected from damage and tampering, and this may involve installing a lockable fuel cap or enclosing the fuel tank in a secure enclosure. In addition, the generator should be located in an area that is free from obstructions and allows for easy access for maintenance and repairs, and adequate clearance around the generator helps facilitate maintenance and repairs. Regular load testing of the generator is recommended to verify its capacity and performance, and load testing helps identify any potential problems with the generator before a power outage occurs. The ATS should be inspected periodically for any signs of wear or damage, and this includes checking the contacts, wiring, and other components, and any damaged components should be replaced promptly. The generator's air filter should be cleaned or replaced regularly to ensure proper engine performance, and a dirty air filter can restrict airflow and reduce engine efficiency. The generator's spark plug should be inspected and replaced as needed to ensure proper combustion, and worn spark plugs can cause misfiring and reduce engine power. The generator's battery should be tested periodically to ensure that it is capable of starting the generator during a power outage, and a weak battery can prevent the generator from starting. The generator's cooling system should be inspected regularly to ensure that it is functioning properly, and overheating can damage the engine. The generator's exhaust system should be inspected for leaks in proper operation, and exhaust leaks can be dangerous and should be repaired immediately. The generator's fuel line should be inspected for leaks in proper connections, and fuel leaks can be a fire hazard and should be repaired immediately. The generator's control panel should be inspected for proper operation, and any error messages should be investigated and corrected, and the control panel provides important information about the generator's status and performance. Furthermore, the generator should be protected from the elements such as rain, snow, and sun, and this may involve installing a weatherproof enclosure or canopy, and protecting the generator from the elements helps prolong its lifespan and prevent damage. The generator should be installed on a level surface to ensure proper operation, and a tilted generator can cause oil starvation and damage. The generator should be secured to prevent theft or vandalism, and this may involve installing a fence or alarm system. In addition, the generator should be located away from flammable materials to prevent fires, and keeping flammable materials away from the generator reduces the risk of fire. The generator should be operated according to the manufacturer's instructions, and following the manufacturer's instructions helps ensure safe and proper operation. The generator should be serviced by a qualified technician to ensure that it is properly maintained and serviced, and the qualified technician has the knowledge and skills to properly maintain the generator. The generator should be inspected annually to ensure that it is in good working condition, and an annual inspection helps identify any potential problems before they become serious. And when operating the generator, be sure to wear appropriate personal protective equipment such as gloves, safety glasses, and hearing protection, and wearing personal protective equipment helps protect against hazards. It is important to be aware of the hazards associated with operating a generator, and this includes electrical shock, fire, and carbon monoxide poisoning, and being aware of the hazards helps prevent accidents. In addition, it is important to follow all safety precautions when operating a generator, and following safety precautions helps ensure safe operation.